Hello, everyone. So we are gonna do division with polynomial. So, but before we get the division with polynomial, let's remember how we do division in general, right? So let's say I'm gonna take 24 and I'll say I'll divide this by 3. So that should be 3 times. So it goes 21. So subtract this. So you got 3. But instead of writing this, I can write 24 equals 3 times 7 plus 3. And this is one way we can write this division. But if I want to divide this equation by 7, so it will be like divide by 7. And I can split this fraction. So you will get 24 over 7 equals like 3 times 7 over 7 is just 3. And then 3 over 7 is 3 over 7. So like why this is a kind of big deal for me now, because when I divide 24 by like 7, I got these guys. So this is the remainder, and then that is the same number that is my remainder. So in this case, like this number and this number just became the same, but they shouldn't be always the case. And this is my like quotient, which is gonna be this number. And then you can take this example with any other different values, but this is how you do the long division, right? But we are gonna do it with the polynomial, so it's gonna be similar. So let's go ahead and write this: 4x cubed minus 14x squared minus 7x minus 4. So what we are going to do, we are going to take this guy and then divide by x minus 4. To do first things first, like we are asking how many 7 goes into this one, right? But we have expression. So we want to look at the term in this expression, which is the highest degree term is x. So how many x or what number, like what expression I need to multiply x by so I can get this highest degree term, which I need to get like 4. So which means I have to get a 4 for sure. X times something should be x cubed. So that means that something has to be x squared. So which means my first term I need to multiply is 4x squared. So now I multiply this guy by the entire expression that we are dividing by. 4x squared times x is 4x cubed. And then 4x squared minus 4 is 16x squared with minus. And then we do the subtraction. So if you feel better to write that subtraction, you may like this, or you can skip those writing this and just subtract. So when you subtract this from that, you get 0, no need to write it. But this negative will become positive because we are subtracting. So negative 14 plus 16 is just 2x squared. And then there is some other terms. We just need to bring those down. So negative 7x minus 4. Okay. And we are going to do the same thing. Like I'm going to get this guy after multiplying x by something. So x times something should be this guy, which is going to be 2x. Because if you multiply 2 by the coefficient 1, that's 2. X times x was x squared, which is good. So I'm going to multiply 2x by x, which is 2x squared. And now 2x times negative 4 is negative 8x. And we do the subtraction again. Okay, so now 2x squared will cancel. So you got negative 7x minus negative 8x. That will become a positive 8x when you subtract. So you get negative 7 plus 8 will be just 1x. And then there is a minus 4 right after. Okay, this is good. This is same as this one. So we are going to ask like what I need to multiply x by so I can get x. That's just 1. So we are going to write 1 right there. So 1 times x is x. 1 times negative 4 is negative 4. So when we do subtraction again, we end up getting a 0. So which means when you divide this guy by this guy, we actually get a expression that has no remainder, which is why this is 0. Okay, so but the question is, how can we write in this form? So by using the same logic we have right here, so I'm going to write this guy. So the 4x squared plus 2x plus 1 is my quotient, which is this 3. So that was right here. So I'm going to go with writing that first. So 4x squared. And then we have 2x, right? And then plus 1. So since my remainder is 0, so I can write as 0 over x minus 4, but that is going to be just 0. So you don't need to write that one because it is divisible by. So that would be just our answer. So I hope that was clear. I'll do another example. So let's see the next one. Okay, so let's try this now, same as before. So we are going to start with writing this expression. So 5x cubed minus 22x squared, and then minus 17x plus 11. And then we are going to take this guy, divide by x minus 5. So it looks like the box looks like radical, but it's just a box that we just separate those. So then x needs to multiply by something to get 5x cubed. So that means my expression, my first term should be 5x squared, because 5x squared times x is 5x cubed. So let's go with that first. But I need to multiply 5x squared by negative 5 as well, which will be negative 25x to the second power. And now we do the subtraction. So when you subtract, these will be gone. So you get positive 25x. And then when you combine these, negative 25 will be positive because of this. So negative 22 plus 25, just 3. So that will be 3x squared. Now we will bring those down. Okay. And we got 3x squared now. I need to multiply x by something to get 3x squared. So that something should be just 3x. So 3x times x will be 3x squared. And then 3x times negative 5 is negative 15x. And then we just do subtraction again. So these will cancel. So you get negative 17 plus 15x, which will be negative 2x. And plus 11. So 11 goes down. So I need to multiply x by something to get negative 2x. So that should be just negative 2. So that will be multiplied by x minus 5. So negative 2 times x is negative 2x. Negative 2 times negative 5 is just 10. And when we do the subtraction again, right? So then these will cancel. So you got 11. This was a positive 10. So 11 minus 10 will be just 1, meaning that my remainder has to be this guy. And my quotient is the expression we have right here. Okay, so if I want to write in the form they want us to write it, so we can just say this should be like this. So we start with the quotient, which is 5x squared. Okay, and then plus 3x, and then plus 11. And that's my quotient. And then I'll have a fractional part that will be k over something. K is my remainder, which is 1. And then something is what we are dividing by, which is x minus 5. We are already kind of told what to write. So what is that look like? Like when you actually simplify this guy, this expression like plus 1 over this, you really need to get the exact same thing on the left side. So this is basically equal to each other. So I hope that was clear. So this is the long division. There is another way that we do, which is called synthetic division. So I'll just do that as well for the sake of practice. Maybe I'll do a little bit more later, but for now, so synthetic division is like a bit simpler than the long division. So what we do is we are trying to divide by x minus 5, right? So that's our goal. So, and then the first step is we can use synthetic division, especially when you are dividing by a linear expression, which is this. And then you are making this guy 0, and then you choose x value that will make that expression 0, which is x equals 5. Okay, so then you just write 5 as your number, and you are excluding this number from the other guys. Okay, and I'll say there's a bunch of different ways to do that, but that's one way to do so. So as soon as we have this 5, and then you just look at the coefficients. So we have 5. Okay, and then we have negative 22. Okay, and then we got negative 17. So you got 11. So when we do the synthetic division, we need to make sure we have every coefficient, like x cubed, x squared, x to the first, x to the 0. So we have, sometimes there will be terms that has no degree looking. Let's say there is like, if you have 5x cubed minus 22x squared plus 11 instead of this guy having, then you should still have a coefficient of x term, which will be 0 in that case. So you should write 0 in that case, but now we do have all this, so we just start with this. So now, as a next step, we make kind of a line to organize our work. So we do take this guy a bit down, so which is going to be 5. Okay, and then as soon as you drag this down, the first coefficient, which is the coefficient of the highest degree term, you multiply this 5 by the number that we have right here, which come from that expression. Thus will be 25. And then we are writing that right below the second number. And then we add these two numbers, negative 22 and 25, which is going to be just 3. And then we write it right here. So we multiply this 3 by this number, which is 15. So we just write right below the next number. And then now we add these two numbers to get negative 2. And then we multiply negative 2 by this, which is negative 10. And then we add these guys again, so you get 1. So the last number in our summation is going to be our remainder, which is same as this guy, as you see. And the other numbers are actually going to be coefficient of my quotient. So this 5 is this 5, this 3 is this 3, and this negative 2 is this negative 3. So sometimes you're going to end up getting like 3 numbers like this, sometimes 5 numbers, sometimes 4 numbers. And then based on the number of numbers that we have, will determine by the degree of the original one. So you will have always some different numbers. But in the case, we have like 3 numbers. So we are going to start with this. Like think about this is your constant term. I mean, not the constant. This is your constant term. So you're going to write negative 2 as your constant. Now you're going to kind of go this direction. So this is the constant term. This is the linear expression, linear term, which means you should have 3x. And then the next one will be quadratic. So the power of the x will increase by 1 as you go from this point to the left. So you will get 5x squared, and that is plus 3. And this is going to be my quotient, which this quotient coming from these numbers. You just write your x's to get your value. So it's kind of better than the long division. As you look at these numbers, when you kind of practice a bit more, it will be way better, especially if you are dividing by some linear factors. So anyway, so this was 2 different ways that we do division. So I hope that was clear. I'll see you in the next video.